Hi everybody, I'm Callan Bentley, and this is...
Mini Professor.
So Mini Professor and I needed to get out of the house. We've been cooped up for too long, and so we got out on the trail. This is one of the trails in the George Washington National Forest outside of Elizabeth Furnace. You can see we've got a beautiful redbud here behind us, Circus canadensis, that's in full bloom. And if you see us going like this in the video, that's because there are gnats all around our heads. That's one of the real hazards to living out here in the Fort Valley, is there's lots of gnats. So if you want to get out of the house and see real rocks in nature, you got to deal with some gnats this time of year. So Baxter, what do we have here?
So we have some sandstone here.
Right. This is sandstone of the Massanutten Formation, but this particular sample of the sandstone is coarser than it usually is, which means it has bigger particles. So it's approaching a gritstone or a conglomerate. You can see those larger, grittier particles. Those imply higher energy water currents to move them as compared to just regular medium or fine-grained sand. And that implies higher energy currents moving these bigger particles. Currents of a certain strength can move particles of a certain size, and if you've got big particles in a sedimentary deposit, it implies that whatever current deposited them must have been strong enough to move them. So this is 400 million year old sandstone that was deposited in this region in a series of braided rivers running into a shallow inland sea, and that was during the Silurian period of geologic time. Anything else you want to say about this?
No, not really.
Okay, well thanks a lot.
That was your rock du jour.